All right, number 3. Describe the graph of this equation. Now, whenever we see that, usually they didn't say make a graph, but we're still kind of early in this. So we're gonna actually go in and make the graph and figure out some of those answers there. So again, what I've done is I've gone ahead and counted off by 5s here, counted off by 50s going up here. I'm gonna plot these points. So 0, 35 is gonna end up being, right, that'd be 25, so 0, 35 is gonna be, oh, no, 0, 0, my mistake. Shoot, 0, 0, sorry. 5, 150, 10, 250, 15 is going to be 300, 20 is going to also be 300, 25 is going to be 250, 30 is going to be 150, and 35 is back down to 0. So now, I don't have an actual point, but you can see that if I went ahead and sketched the graph, you can see that something's going to go on up here. It's going to kind of come up here and curve back down and come back around and make our way down back to this point. Okay? So that's what our graph would look like. We had that same kind of curve, but you see we don't have an exact point yet figured out, but we kind of see where that maximum point would be. In fact, look at number 4. What is the maximum area? What dimensions correspond to this maximum area? We got to explain that. So what we've been seeing so far is that that maximum area ends up being at the exact midpoint. And that midpoint comes right through here. That midpoint would also run right through here. So we need to figure out what that would end up being. So the exact midpoint, well, what is that midpoint between 15 and 20? Well, right in the middle of that would be taking the difference, dividing it by 2, and adding it to 15. But I can know that right in the middle, that's going to be a 17.5. So if I put that 17.5, that'd be right here, 17.5 in there for this 35. And if I do 35 minus the 17.5, that's going to be halfway as well too, right? So we get 17.5 for that width. I need to find that actual area. So if I do that, if I do 17.5 times 17.5, I actually get 306.25. So 306.25, and that actually would be the peak right here. That's the maximum area. So in this case, for that particular question, the maximum area, which is going to be for number 4, so max area is equal to 306.25 meters squared. And the question that comes up after that as well says, well, what dimensions correspond to that? So the length is equal to 17.5 meters. The width equals 17.5 meters to get that. Again, it's a square that shows the maximum area for this. All right, number 5. Describe 2 ways you could find the fixed perimeter. What is the fixed perimeter? Okay, so 2 different ways we could do this that I see right away is we could actually draw a rectangle with some of these dimensions, or draw a square with those dimensions. So I'm actually going to think about drawing a square with. This is the one that we just found. So because the length is going to be 17.5, the width is going to be 17.5, so I can actually draw this. One way is to draw this. I'm just going to draw a square. And I know this is going to be a 17.5 meters. This is 17.5 meters. That means this would be 17.5 meters. This is 17.5 meters. So to do that, to find the perimeter, I would have 17.5 times 4, which would give me 70. So 17.5 times 4 equals 70. So the perimeter is equal to 70. Now that's one way to do it. The other way goes back to what we did at the very, very beginning. If you recall, we talked about the 60 meters and noticing how all the way around these 2 guys were half of that. So you can see how we had that these 2 guys had to equal 30. It would be half of that perimeter. Well, look what they gave us in this initial equation. They gave us a 35. That means that the length and width by themselves add up to 35. So we can take that equation there and multiply that times 2. So we can also do that 35 times 2 would equal 70 as well. So that again directs us to the perimeter being all right. Part C. Suppose you know the perimeter of a rectangle. How can you write an equation for the area in terms of the length of a side? Okay, so now they're not telling us the numbers, We have to remember those details. Okay, so first of all, we got to remember area is equal to length times width. So we can't forget that. We also need to remember that perimeter is equal to length plus width all the way around. Or perimeter is going to be equal to 2 times the length plus 2 times the width. So either of those options really help us to figure this out. And we can't even go a step further and factor this out. Remember, we were going from expanded form to factored form. We see that perimeter is equal to 2 times the length plus the width. So same idea, we factor with that 2 to come back to factored form. So in this case, we got to think about that in terms of area. So we realized that what we were doing is we took that area, we still had our length, so area is equal to length, but the way we found the width is we ended up taking half of the perimeter and then subtracting that from the length. Because remember, as we showed here before, that the half of this guy, there's that 70, we had 35, would be half of 70. So we need to take that perimeter, we're gonna multiply it times the half of that perimeter, and then minus that length. And that's how we would get that if we knew the perimeter for any shape. Part D, study the graphs, tables, and equations for areas of rectangles with fixed perimeters. Which representation is most useful for finding the maximum area? Which is the most useful for finding the fixed perimeter? Well, really, this comes down to what your preferences are. We see things in the graphs and the tables. The graphs are very visual. We can see that maximum point where that top peak is of the parabola, and that shows what the maximum area would be. You could also see the table as well too, if you're looking at the way the data was working its way down, and then actually had one piece over there where you can see how that specific length showed the highest specific area. That'd be another way that you can show. So then which of those methods also, the table, graphs, or equations, is the most useful in finding the fixed perimeter? It kind of feels like, again, your preference, but if I have that equation, I know that whatever the length times that half of the perimeter minus the length, I can just take that 35 like we did, or the 30 we did today, multiply that times 2, that would be how I could find the fixed perimeter. Or I could go and actually take some of the data that I had from the table and then draw a rectangle around with those dimensions as well too. Either way, it's really your preference. All right, so for today's ACE work, we're going to be looking at numbers 7 through 14. And so here it is, number 7. The equation for the areas of rectangles with a certain fixed perimeter is, here it is, area equals length. All right, number 7. So the equation they give us here is about a rectangle with a fixed perimeter. There it is, area equals length times a 20 minus the length, where length is in meters. Describe a graph. Obviously, you could describe it, you could just make it. Either's are going to be easy, just fine. What's the maximum area for this rectangle? What's the dimensions there? And explain. The rectangle with this perimeter has a length of 15 meters. What's the area? Describe 2 ways you can find the perimeter. What's the perimeter? Okay. Same thing with number 8. Rectangle has a perimeter of 50 meters with a side length of L. Express the other dimension in terms of L. Write an equation, sketch a graph. Same work that we just did. Number 9, here's a perimeter. Here's a rectangle with perimeters 30. What's the dimensions in terms of L? Write an equation, make a graph. It's all the same stuff that we just got done doing. Okay, number 10, copy and complete the graph to show the areas of rectangles with a fixed perimeter. So I want you to make this and complete it, and you're going to find lengths greater than 3 meters. So you need to keep going all the way through, because you already have 3, so you need to do 4, 5, 6, 7, all the way in there to figure out that graph coming there. Make a table. What's the maximum area? What are the dimensions? Number 11, based on this, which equation goes with number 10? So you have these choices to go with. Number 12, copy and complete the table to show the areas for rectangles here. So this is the table down here, okay? And it turns out that make a graph of this relationship. What's the maximum, what's the dimensions of rectangle with the maximum area? There's multiple choice for that information there. And then lastly, number 14, here's the equation they give already. Make a table and a graph. Estimate the price that will produce the maximum profit. How the table and graph from the situation similar to those made in problem 1.1. All right, guys, it's getting a little bit more involved. This is going to be the last one that we work on specifically from this investigation or this book. We're going to go back to say it with symbols after this for problem 4.2 and finish that up. All right, we'll see you guys next time.